This is Harnessing Observability for Platform Engineering. My name is Josh. With me are Paige and Ryan from Chronosphere. All right. So a little bit about what we're going to present. Today's agenda. Pulumi in a nutshell is actually going to be coming later. First, Paige is going to speak. It's going to be story time for platform engineering because that's what the dev roles do. And next, we're going to talk a little bit about a demo for controlling cost with control plane. And then we're going to do another demo on systemic troubleshooting with DDX. And then finally, we're going to show a nice demo that ties together both Pulumi and Chronosphere. Cool. All right, so let's get started. So for this one, is this Paige or a Ryan slide? I guess this might be a me slide. So if you are following along with the demo later on, this is a list of the things that you need. I believe this is also documented in the README in the workshop repository. So I will put that onto the handouts tab. All right. Cool. All right, Paige. I think it's your turn.
All right. Hi, everybody. Good morning, afternoon, evening. Looks like we've got a bit of a global audience today. I wanted to kick things off by sharing a story from my SRE days where I effectively was an internal tools or platform engineer that I think may resonate with some of you. But before I dive in, I want you to think about the last time you or an engineer at your company had to launch a new service. How much time was spent setting up monitoring, alerting? How confident were you in those alerting thresholds? And was it toilsome or was it pretty straightforward and a nice paved path? Keep that in mind as I tell you the story of when I click the slides. Okay, now I know how it works. So I used to work at a little company called Lightstep that focused on distributed traces. We were migrating our metrics from Datadog to ourselves, and it was a bigger endeavor than we thought. We had been managing alerts as code for a long time, and we thought the easiest way to migrate between observability vendors was grab everything we had dashboard-wise and turn it into dashboards as code, and then do some sort of translation layer to translate it into what a Lightstep dashboard as code would look like. And boom, we'd have one tool that does the conversion. It'd be super easy. And then going forward, all our devs could manage their monitors and their dashboards as code. Simple enough, right? Big scare quotes there. Because what actually happened was we landed in this messy hybrid state for a super long time where some developers and some teams would make changes just in the UI. Some were following the process. But every Monday morning, it was my job to make sure the massive diffs that were generated for the last week were reconciled. And it did not matter how many documentation items I wrote, how many targeted Slack messages I sent to the people who I knew made the UI changes, or engineering all hands updates. I tried multiple ways to communicate to people that they needed to follow the new process and what the process was. But weeks and weeks went by and I was stuck in this doom loop of toil. And the cherry on top was that we had just moved to environment-specific workspaces. So what used to be one command to manage all your alerts across every environment turned into 6. 2, 1 to get in the right environment, and another to apply, times 3 environments that we had. So it wasn't that I was just asking devs to manage dashboards as code. I was also really moving their cheese. I was really changing how they did that management. So this led me to the big learning that if people aren't following the process isn't working. That can feel really hard when we on platforms spend time in making what we think is this beautiful, easy to follow, sensible, straightforward process. But sometimes the absence of data, the absence of people following that process is data, and it is important feedback to take into consideration. So I think this kind of gets to the heart of why we're all here today, because when we talk about observability as code or monitoring as code, it's not just about taking what you've got and throwing some Pulumi on it and hoping for the best. we really want to think about creating a system that works with your teams, not against them. Not basically not how I did it at my last a few companies ago. So I think there's kind of three big pitfalls with status quo observability and monitoring today that we see. So the first biggest hurdle, I think, is fragmented tooling. So when you've got one observability platform per signal, like this is just where metrics go, this is just where logs go, this is just our tracing tool. Those data silos create really big gaps in visibility. And that's when you've got folks jumping between tabs and tools and query languages just to try and piece together what the heck is going on. So yeah, I've just seen teams spend so much time figuring out where the data they need to access is and less time actually using that data. The second is centralized support. So in my previous life, I was the person that was doing help desk chat support. I was answering the tickets. I had to make sure those diffs were reconciled. And that is just not a scalable model. One of the whole goals of platform engineering is that self-service engineers can do self-service. They can get everything they need for the software development lifecycle via your platform, and hopefully not having you as a bottleneck or having to have you do a lot of toil to set things up. The centralized support model just does not scale. It may be fine as you get started, but it does not scale. And finally, kind of what I call the afterthought problem, where I've seen lots of organizations treat observability and monitoring as something you kind of bolt on at the end of deployment or right before you're about to launch. It's like, oh, who set up the alerts for this? But I kind of think that's like trying to add seatbelts to a car that's already like cruising down the highway. It's going to be a little bit riskier and it's going to take a lot more work to get that done. So these things, the fragmented tooling and the data silos, the you as the centralized support sort of bottleneck, and this sort of idea that observability is something you add on after, or the idea that observability and monitoring is like platform's job or SRE's job, or that's what the infra folks do. No, observability is everybody's job, as is monitoring. So there is a better way, which is why you're here today. So you will see a more in-depth demo, but I wanted to highlight probably my favorite feature that we've got, which is our service maps. When a developer deploys a new service using Pulumi and Chronosphere, it will automatically appear on a service or dependency map like this, fully instrumented. And this isn't just like a pretty picture, boxes and lines. This becomes a living, breathing architecture diagram that also shows your system health. In this view, I've dropped down to highlight the errors so we can see that errors are down between like order and billing or portal and order service. But you could also do it by throughput. You could do it by latency like P99. It's very powerful to have this view of who depends on me and who do I depend on, all in one view, easy to navigate. So this is where we see my very good slide image picking skills. This is where Pulumi and Chronosphere's integration becomes super powerful, because we're not just treating infrastructure as code as your data stores, your VPCs, your pods, however you manage it. It's also your dashboards, your monitors, your SLOs. It's everything that you need to build, operate, scale, run, troubleshoot a service, all defined in config as code. Very, very powerful. And I think my favorite thing is that developers get to do it in a language that is familiar with them. I love Pulumi for making that, bringing that concept to everybody. Having tried to teach developers HCL, I can tell you it does not always go well. It's quite a bumpy ride. So our big goal, what this means for your developers, when you use Pulumi and Chronosphere together and you've got these beautiful templates, you've made it easy for them to spin up a new service with everything they need. That is your self-service observability. That is that holy grail. They get to define the things that they need in their terms, in their way, living possibly within their repo, all co-located. And you get templates, guardrails, version controls, and giving developers that autonomy instead of chasing them around with a stick and saying, you have to follow this process. I'm so sick of reconciling dashboard diffs. You give them this beautiful carrot, this beautiful golden path that they want to walk down. So there is a better way forward. Had I had Chronosphere and Pulumi by my side back in the day, and had taken a step back to realize that if people aren't following the process isn't working, and really looked at maybe adding an abstraction layer or a wrapper, or really just realizing the process I was trying to force, even though I was responsible for making sure there were no diffs at the end of the day, I needed to be working in collaboration with my developers, not maybe as this enforcer. So when you integrate observability into your IDP, it becomes what it should have been all along, just a natural part throughout the entire process of how we build and run our systems today, and definitely not an afterthought. I would love to hear if you have had any of these pain points or if this resonated. And in particular, I would love if in the chat you shared your definition of observability, kind of on a mission to collect them all. And I think there are probably like 20 different definitions I come across on the interwebs, but I'd love to hear your take on it. And with that, I will pass the baton over so we can dive into a demo of what Chronosphere's got going on for you in terms of cost control and developer experience.
All right, Ryan, I think that is your cue.
Gotcha. Okay. Josh, did we want to cover the Pulumi overview briefly first?
Yes. Sorry, I believe that would be my cue. All right. So, a little bit about Pulumi first. So the aspects of Pulumi. So Pulumi has 3 products. There's another slide that's coming up that will show you what they are. But the one that we're best known for, our oldest product, is our infrastructure as code product. It has 2 essential characteristics that kind of make it unique in the space. One is that it allows you to use general purpose languages, and there are other tools that do allow you to do that. But it's combining that ability to use general purpose languages to express your infrastructure along with a multi-cloud along with the ability to manage resources in multiple clouds or SaaS services. So when we say general purpose languages, the languages we support specifically are Node, Python, .NET, Go, Java, and then we also have the ability to support YAML as well. And then when we talk about any cloud, well, we support all the major hyperscalers, AWS, Azure, Google Cloud. We also have a Kubernetes provider that's very popular. But then we also support a long list of different SaaS and smaller cloud providers, among which are also Chronosphere. And you can also do things like orchestrate on-call schedules with like PagerDuty. We have a large list of different providers that we support. I think it's rapidly approaching 200. I think there's a couple more. I think we're at least over 190 at present. And you can see the complete list of providers that we support in the Pulumi registry. And I will put that link on the handouts tab or drop it in the chat. So like, how does a Pulumi program work? Essentially at the top level, you have a project. A project is it is a folder that has a Pulumi program in it. Within your Pulumi program, if let's say you're writing in Node, that would be like index.ts or index.js, whatever the sort of canonical entry point is for your language of choice. So in Go, it's main.go, so on and so forth. Within your program, you're going to define resources. Resources are your desired state for something that Pulumi can control. That might be a Chronosphere dashboard, or it might be an AWS VPC. Resources have inputs and they have outputs. Inputs are things that you can define. They may also have a default value. So for example, if we take an AWS VPC as an example, the VPC CIDR block will default to 10.0.0.0/16, but you could also define it. So that's an input. So the things you can define. An example of output is the VPC ID, and these are typically things that you only know after the thing has been provisioned. So with a VPC, it might be the ID. If you're provisioning a load balancer, it might be the DNS name of the load balancer. And so the way that Pulumi programs work is you have these resources, they have inputs, they have outputs. Very commonly, one resource's output is another resource's input. So for example, if you created a VPC, that VPC ID would feed into the subnets that you put into that VPC, to take a very simple example. And so what's going on behind the scenes is Pulumi's keeping track of these inputs and outputs, and it knows what depends on what. and it basically does a diff against the work that has been done, which is stored in your Pulumi state file, and it basically diffs what you have versus what you want, and it will figure out what needs to be changed in what order. In other words, what needs to be created, updated, or deleted, and it figures out the dependencies between all of these things. And that's what makes Pulumi so powerful, is that it is like this declarative tool, right? You don't have to say create the VPC if it hasn't already been created. Instead, we already know that it's been created, and then we can figure out what needs to change and in what order in order to get the state that you want. So that covers the program. And then you can, there's this concept in Pulumi of a stack. A stack is essentially an instance of a Pulumi program. Very common pattern is to have like a dev QA and prod stack, or dev staging and prod stack. Each stack has its own configuration values. So you can do something like, I don't want CloudWatch logging. I don't want logs to be retained for my VPC in my dev environment. But I do want them in the prod environment. And so you can put config values into your stack configuration files, including secrets, by the way. I'll get into this a little bit more in just a minute. And in this way, you get the reuse of your Pulumi program for multiple environments. And then within your Pulumi program, you can read those stack configuration values to drive the behavior of the infrastructure you're creating. So a little bit of a comparison between the other tools in the space. So Pulumi, again, allows you to use general purpose languages. The reason that that's more powerful is you're going to be able to use intuitive syntax. So if you want to use a for loop, you're just writing a for loop in whatever the language is that you're using. There's no special syntax involved, as opposed to other tools where like you're going to have to learn like some bespoke kind of way of like taking a slice of an array or doing a for loop. They can get very, very awkward when you have to do that at scale. In addition, using general purpose languages gives you the advantage of being able to leverage that ecosystem. So if your network team, for example, keeps some sort of like IP address allow list or like CIDR blocks in a Google Sheet, you can just leverage the Google Sheets SDK and use that to drive, say, firewall rules or network CIDR blocks or whatever it is you're doing. And so in that way, general purpose languages are also super helpful. You can also, by the way, share Pulumi code using the packaging system of whatever the general purpose language is that you're using. So if you are in the Node world, you can make Pulumi NPM packages and then consume them in other Pulumi programs. And then second, you have that advantage of being able to work with any cloud. And again, we have a large list of cloud providers and SaaS providers that we work with. The execution model for Pulumi is similar to Terraform. It executes from your local CLI or your local machine, or if you're in a CI/CD pipeline, it's going to execute from the pipeline machine. The contrast here is that you don't hand it off to some centralized service to execute on your behalf, and that leads to faster feedback. And we also, by the way, do not attempt to transactionalize so there's no rollback involved if a Pulumi program fails in the middle. If a Pulumi program fails in the middle, then whatever work is done, and we don't try to undo it. And you can modify the program and try again from there. And then finally, we have really good secrets handling. So we know which things are a secret in your state file. Like, for example, if you create an RDS cluster, we know that master password is a secret, and we will only store the ciphertext in your state file. So if your state file were to leak, you would not have to worry about your secrets leaking. They are encrypted in transit and in rest. And you can also, by the way, mark stack configuration values as secrets, and then they will be stored only in ciphertext. So that means that you can commit your stack configuration files to Git, and then you don't have to worry about other people being able to view secrets. And then finally, just to give the picture of the whole platform. So everything I've talked about so far is Pulumi infrastructure as code, but we also have two more products that just to be aware of. We have Pulumi ESC, which is essentially a way to grab secrets with centralized RBAC from a bunch of different sources. So those sources might be different cloud providers, secret services. You can store secrets. You can store secrets in ESC itself. Or you can store them in a bunch of different secrets providers, 1Password, AWS Secrets Manager, even HashiCorp Vault, so on and so forth. And so the advantage of this is that it allows users and developers to grab secrets from a bunch of disparate sources with the RBAC all done in one place. And you can take those secrets, by the way, and hand them off to any command line process, including Pulumi programs, infrastructure as code programs as configuration. And then finally, we have Pulumi Insights. Pulumi Insights, basically the way it works is you give us an environment. We will scan that environment and take an inventory of your assets, and then you can do things with those assets, including like create visualization. So let's say that you have you want to know how many teams at your organization are using like an old version of MySQL in RDS. We can help you track the progress of those sort of migration efforts. And there's a lot more you can do with Pulumi Insights. And if you would like to learn more about that, there will be an upcoming workshop on it. So keep an eye on your email. All right, Ryan, I think I'm handing off to you now. By the way, if you have any questions about Pulumi, please feel free to ask in the Q&A tab, and I will do my best to answer there.
Yes. Yeah, so it's time for the hands-on and demo portion. So I'm Ryan. I'm a sales engineer at Chronosphere, and I focus on integrating with a lot of our partners, in this case, Pulumi. So before we get into the hands-on workshop and dive into code and a lot of that fun stuff, I wanted to give a quick overview of what Chronosphere is, maybe how it's a little bit different in the market, and then show a very quick demo just to show you that, if you do this right, what does it look like in production? What do teams actually gain? And then specifically, how can Chronosphere actually help resolve an issue? And how can we do that really effectively? And then lastly, observability is great, but it does not normally come for free. So how can we control that cost so that we have a long-term, healthy and successful approach? It not only solves issues, drives your MTTX, but also doesn't break the bank as much as it historically has. And with that, I can switch over here. Okay. So I've dropped us in to our Chronosphere, one of our teams here, and this is an ordering team. So what we're seeing is a list of services that's owned by this team. And then we also see a list of monitors and dashboards. And we could talk about that. We're going to loop back to those more and some of those capabilities. But for now, we're going to drill in and say, hey, I see a service that has an issue, the ordering service. So I'm going to click into that. Excuse me. And now what we're looking at is our service overview page. So one thing I want to highlight, Chronosphere focuses on being compliant with open source data collection. That means we don't have a proprietary collection agent, so we don't control the schema of the data that we do collect. So this is a combination of Prometheus, OTel, FluentBit telemetry. We're receiving that information, mapping that by a service label, and then displaying that in one centralized view. We can also visualize our change events. So we see in this case, and let me change the time frame. Actually, this is perfect. We see right here, errors per second is starting to spike and has triggered an alert. And right before that alert, we actually see there's a feature flag. And I'm going to click right into our feature flag. And this is launch darkly, which is telling me that there's been a recent change. And I can see that, okay, we've enabled Amex card support. So just because that feature flag was triggered right before the increase in errors, I'm going to keep that in mind. Scrolling down, this is the wonderful dependency map that Paige had highlighted earlier. And because there's a spike in errors, I'm actually going to sort the trend by errors. And this will let me quickly visualize where there's actually an increase. So we'll start right up top. I can see this red arrow indicating there's a trend that's increasing. 12% increase in errors. And I actually have the option to jump into one of our features called differential diagnosis, which is what I'm going to do here. And differential diagnosis is a tracing feature for us that instead of relying on testing your hypotheses with a set of individual queries or looking at individual traces, it lets you analyze all at once at a very high level what's different in your failed spans versus your successful spans to try to get to that root cause analysis as quick as possible. So I open this window, and what I'm going to do is enable some of our suggested tags, and I'm going to sort our graphs to sync to the error spans. What this has done is listed out of all the spans that are related to those services, what are the available pieces of information we have, and we can compare directly. So I can see in my errors, 97% of the errors had this build version. That's only true in 32% of the successes. And interestingly, we see this card brand Amex present in 96% of the failures and only 6% of the successes. So I know that we saw that feature flag was related to enabling this card brand. So I'm going to click into this. And now I do want to check some granular trace data. So I'll go into my view traces. This has now provided us with a list of these specific traces that I know are interesting to me. So I'll open up one of these traces. And this is kind of what you'd expect with a trace viewer. And from here, I have links to all of our related telemetry types, whether that be the logs, metrics, or events. And I can also search in this trace for Amex to see where this shows up. And with our billing service, there's an error here where if I scroll down or up, I can see that my card brand is Amex. So if I was actually troubleshooting this and looking for a full fix, I'd probably want to check out the logs, jump into my code. But from here, I have a pretty good idea of what the issue is. So I'm going to shift gears in our demo, and I'm now going to talk about how you might use Chronosphere to control cost and do this in an effective long-term strategy.
Hey
So
Ryan, quick,
yeah.
are you able to zoom in a little bit more on the browser?
Yeah, let me see here.
Yeah, there we go.
Okay, perfect.
It's always larger than you think it. It always needs to be larger than you think it does.
Yeah, no, I appreciate that. So the way we're going to look at cost control is we're going to jump over to our admin panel. And if I go to our control features, we're going to start with a view called our metrics quotas. This view is built to help you understand when you're at risk of having an overage or a cost issue. So we want to make it very clear that, hey, there's an issue that might cause you to spend more than you planned. In the market traditionally, the way you'd be notified of this is maybe when your bank runs out of money and they tell you that there's no money left to pay for your tracing. So that's what we want to avoid. In this case, we're looking at metrics, and we can see in red that our ordering team is actually above their quota consumption. And so we want to not only notify you that, hey, you're at risk of this cost issue, we want to give you tools to actually resolve it. So the flow that I would follow, the next things that we can show, we have these concepts of aggregation rules and drop rules. These are interesting because as Chronosphere ingests all this open source data, you have the chance to aggregate, drop, and shape the data before it's retained and incurs higher cost. And so that's what we want to do in this case to control this issue. So we're going to go to our analyzers, and we're going to open a page we call our live telemetry analyzer. We have this for traces and metrics, but again, for this demo, I'm just going to focus on the metrics workflow. And if I capture live data, I like to joke that this feels like you're being plugged into the matrix if you're an SRE, because you get this stream of data, and if you don't know what you're looking at, it can be overwhelming. But if this is a system you're familiar with or you're trying to learn, it can be really helpful to visualize just raw data that's passing through the system. And this might help you create some theories or just get a high-level view. But we do want to go a level further than that. So we have this telemetry usage analyzer. And this is what's going to actually lead to the change, right? So another thing that's different with Chronosphere is we actually give you the ability to make these changes from within the platform, where traditionally you might need to go back to a development team and say, hey, I know that last time you had an incident, you didn't have enough instrumentation and visibility, so you couldn't resolve that issue. Therefore, you instrumented more things. Now you've incurred too much cost, and we need to take that away. This can be kind of a nonstop negotiation, and you get stuck trying to get in the backlog cycles to make actual changes. Chronosphere lets you do this right from the platform, which is really helpful. But one other thing I want to show, we're sorting our metrics by least valuable. This implies that we can measure the value of your metrics. And the way that we do that is by this utility score and the data points per second that are being persisted. So we can see that utility is 0. And the way we calculate that for a metric is to look at, hey, how many configuration references does this metric have? This is dashboards, monitors, SLOs, queries. And then we have these direct query execution indicator as well. Right now, we can see this metric is not being used in any resources, and it's also not being queried. But we're paying, a decent amount because we're storing this metric at a relatively high rate. So the recommended action here would be just to drop this metric because it's probably safe. And you can do that right from this UI. There's a lot of configuration and options we have around the aggregation and drop rules. So we're not going to be able to get into that today. But if you're interested, definitely reach out. This is a strength of our platform. And it's also nice too, because maybe you're instrumenting something, you don't know exactly what you need yet. You can have a higher level of instrumentation, drop and aggregate within the platform. And then once you're more confident with exactly what you need, that's when you can go back and change at the developer and instrumentation level. That's the demo of the product. So if there's any questions, feel free to toss those in the chat. And then we're going to transition to our hands-on portion. I can actually probably go back to our slides.
Yeah, and it's also worth noting. So the link to this code is available in the handouts tab, along with the downloadable workshop slides, and also a link to the Pulumi registry where you can see the complete list of providers that Pulumi offers.
Yep. Thanks, Josh. And so first, I'm going to overview the hands-on portion and kind of get us oriented into the scenario and the things that we're going to be doing. So we are going to put ourselves in the position of an engineering team that's launching a new app, and we may be we might be the platform team that's supporting an engineering team, and we're trying to build templates to make it easy for them to deploy. We can also think about this from the perspective of, hey, maybe I'm the lead developer and I'm taking this on from within my team, and we're going to own our infrastructure as code. We're going to deploy a simple web app or store that's just an express backend that delivers a web page. We're going to deploy this to GCP as a cloud run service, and we're also going to use Google's Artifact registry to store the container images. And while we deploy this to Paige's point, you want to remove toil, not add it. So because we're using OTel, we want to deploy an OTel collector with this deployment so that we can scale our application containers, and then we still have at least a collector that can support that and scale as well. And then lastly, once we have this deployment, we want to include our observability resources and visualizations. So that's going to be Chronosphere dashboards, monitors, and we're also going to do a synthetic API check. And that is going to kind of produce some traffic. So I like to always include a synthetic check with a deployment. So right away, we're driving live traffic. Oh, and I'm getting a network indicator. Hopefully everything's fine. Somebody let me know if I'm lagging.
Sounds all good from where I sit.
Awesome. And then lastly, we're going to think about how you could templatize this deployment within Pulumi. And I have my picture of Bob Ross here because one thing for me, one reason that I like to use Pulumi in my projects is the flexibility that it brings. We can kind of make our happy little dashboards and IAC in the way that works for us, right? There's not as many strict rules we need to follow. Okay, we'll keep this moving for the sake of time. I'm jumping over to our repository, and hopefully you can see a little bit, but I just want to highlight the setup steps that I've done already, which is configuring our GCP setup, logging into Pulumi, created a new Pulumi project, and I have set up some variables. But again, this is in the repository, so you can follow along pretty easily. And then lastly, I've actually defined our Chronosphere and Checkly account and API keys as environment variables in this deployment. So the next thing we can do is actually open up the IDE, and we can go through our application and then see how this looks when it's deployed. So the first thing is I'll just talk about the structure. We have an application folder. This holds our application, which is very simple. And you'll notice there's no monitoring code in the actual application. That's handled within our Docker file, or excuse me, our package JSON, just by modifying the startup script to include the OpenTelemetry auto instrumentation package before we run our server. We also have our index.html. This is just a static web page. Our Chronosphere folder here contains some observability resources, but we're actually going to loop back on this later on. We also have a collector folder. This is where we store our OTel collector configurations. I kept this as simple as I could for the demo, and I'm passing some of these configuration items through as environment variables, using Docker to capture these arguments from Pulumi and pass them into our running collector. And apologies for going fast. I have this laid out in the README, but just for sake of time, I'm moving a little bit quick here. Okay, outside of that, the important one to take a look at is our index.ts, which is the script that actually defines our Pulumi up actions. So I'll go through this and then we'll take a look at the output of our Pulumi up. But the first thing we're doing is configuration. And this is just simply making sure that our project knows what region we're using in GCP, what our project name is, and then we're actually defining a repository name to store our images. Next thing is actually spinning up an artifact registry and building and pushing the images. And so we're taking these different configuration items and we're creating the string that defines where these live. Pulumi is going to create the image repository for us. And then we have a command that's building and pushing these containers however we'd like. Again, in this case, I'm taking some of our environment variables. This is where you could use Pulumi's secret storage, anything you'd like there. And another thing to call out, when I was building this, most of these resources did not take long to define. I just used Pulumi has a really awesome AI feature where anything you're trying to do with Pulumi resources makes that easy for you.
Yeah, it's also worth noting we have a Docker provider and a Docker build provider as well. So if you want to build images locally, the Docker provider is good. And then we have if you want to use Docker Build Cloud, we also have a provider that allows that.
Yep, and that's just underscoring again that flexibility that I really enjoy with Pulumi. The next thing here is we're defining the OTel collector cloud run service. So this, I don't know if we can fit in this full screen here. We're defining our cloud run service, pulling in some of these different variables, setting some auto scaling information, and then defining some of our collector specific configurations. But ultimately, there's not a ton to add here. Most of this, again, is defined in that OTel collector config. The goal is to make deploying the OTel collector and providing auto instrumentation as easy as possible for the teams that are going to use this template. And then lastly, for each of these services we define, we're going to create an IAM member that just allows anyone to invoke this. And then to Josh's point earlier, we're going to expose this URL and we'll be able to use that later so our application knows where to send the telemetry to connect to this collector. Next thing we're going to do is define our applications cloud run service. So similar to our OTel collector, we're going to define the region, set our auto scaling, our different ports and things like this. But this is also really handy because I can define some of my OTel configurations related to sampling. In this case, I'm setting it to always on. And then I can also set the level of logging I'd like and different OTel configurations, service names, things like this. This is also a good example where we can see, where's my scroll bar here? We can see we're using the output from our collector service to get that URL dynamically. Okay, last thing, and then we're going to check our first Pulumi run. But we're actually creating this checkly synthetic test. We're just defining a very simple browser check to say, hey, is this available? And that's going to drive some traffic when we do deploy, and also give us some observability data right off the bat. So I'll open up my shell here, and we can see my last command of Pulumi up. Already ran this to save some time, but this is what it does. It goes through, verifies what you want to update, performs those updates, and we actually get an output of our app service URL as well as some of the observability resource IDs. So from here, let's go back to our UI and let's check out what things look like. Our application looks like it's running, and this is built to fail around half the time. So if I refresh this a bunch, we'll get some baked in errors just to make our data a little bit more interesting out of the gate. And this is Checkly. This is the synthetic provider that we're using. The reason I like Checkly is because they use Playwright, which is open source, and each synthetic check that they run against your API also produces an OTel trace, which can be ingested and visualized in Chronosphere. So we have that all in one place. But the next thing we want to do, if I open up my IDE, I do have some code here defined for Chronosphere dashboards and monitors. I have that commented out because I wanted to start without these resources and then show what it looks like to add them. So that's what we're going to do next. So I'm going to jump back into Chronosphere. And what I'm looking at now is our Pulumi service, or excuse me, Pulumi workshop service. So just like we saw in the demo with ordering service, out of the box, Chronosphere has detected and defined a service overview, which at the moment looks pretty boring because this service isn't talking to any other services directly. So out of the box, we might want to add additional visualizations, additional monitors that are more interesting and a little bit more customized to our needs. So I mocked a dashboard up, and we're going to talk about how we would build this dashboard and then how we would transfer this into Pulumi and actually get these resources as part of our deployment in a template. So we have a few things up top here. We have requests per second, errors, and duration. This is following the pattern along the lines of your red metrics. And then at the bottom, we have our topology map, and that's easy to add as well. And so what we'll do is we'll jump in and look at each one of these items and what it takes to build these. So first, our request graph, very simple query. I'm just grabbing the actual raw request. And the reason that this metric is named Pulumi Workshop Request is because I have actually defined a trace metric to name these very clearly, but you could have this be HTTP request with a service tag as well. All the visualization settings I left as defaults, but we do have a lot of options as far as how we want this graph to look. And then lastly, what's important here for us is this JSON. I could pull this out and use this right in my Pulumi script, but I'm actually going to take the JSON at the dashboard level instead of the individual graph level. And we'll briefly take a look. Nothing too different here, but for errors, we're looking at our workshop request where error is true. And instead of treating this as a rate, we're just taking the raw results of these queries. And duration, this is kind of an ugly query. So if anybody in the chat has a better version of this, feel free to share that. I have no problem having my code and queries roasted. But again, something to give us an indication of what the duration of these requests are.
I've certainly seen worse queries.
Hey, I'll take it. And then lastly, our topology. This is really simple to add with Chronosphere. All you have to do is just select the type of service topology. Everything else is defaults. And this will look at the live telemetry and try to identify which services are actually being communicated. And even if it's not, it can still show, hey, you're not communicating to anything else, but we're going to show you right next to this big web of other services. So from here, we want to grab our dashboards JSON. So we make that easy, and all we need to do is grab this, copy this over, and you can use this just as a JSON file, or you could use this as a string. Well, if we open our IDE back up, this is where we'll go back to this Chronosphere library we talked about earlier, folder, and I'll open our dashboard config.json. I've already transferred that mockup JSON into this file, but you can see here, this is very easy to read, understand, and update. And so if I go back to our index, I'll actually uncomment this code. And we can see here, I'm just parsing this as a file. And I'm doing a little bit of interesting parsing here because this can be just one big JSON file, but you also might want to take the JSON, dashboard JSON as a string. And so this just ensures that either way, it will be formatted correctly.
Yeah, this is like a couple interesting points here. One, this is like a perfect example of, the power of general purpose languages in infrastructure as code. And the other thing that I'd like to offer is that, like, normally you don't want to do like visual design first and then put it into infrastructure as code. Like, for example, like you probably don't want to spin up your VPCs using like a wizard in the AWS console. But this is actually an exception to that, because writing this JSON by hand would be extraordinarily difficult, and even with good performance on any infrastructure as code tool would be a pretty slow feedback cycle. So just in general, if you're trying to do infrastructure as code all the things, then there are some exceptions to this sort of code first approach, and I think that dashboards, for example, are a great example of like where you want to break that pattern.
Yeah, no, I absolutely cannot agree more. And it's kind of interesting because once you actually get started and you get the initial starting point, then it does become down the line easier to come and tweak this. And I've actually found that I was a programmer first, right? That's where I started. So if that's your mindset, it's much harder for me to go into like the GCP console and understand all of those different options. But if I see that in the Pulumi provider, I can understand through the docs what's available to me and what's not, even if I don't know how to navigate a UI. That's extremely helpful in my view. So the last thing we're going to do here is add a monitor, which is what we use to look at a query and then alert when those thresholds are violated. The code here is very similar to what we're doing with the dashboard, which is reading in that file, using the Pulumi provider to actually create that resource, and then exporting the name. And again, the way that it knows what Chronosphere account and API key to use is because we've exported that as an environment variable in our shell. Again, that can be stored as a Pulumi config or secret. I just chose to take that path for this example. So I'll open back up our Chronosphere UI here. The next thing I have mocked up is a nice monitor with some thresholds. And I'll go through this quickly because we're almost up on time. But if I click Edit Monitor, I'll just walk you through kind of what this looks like. We have an owner, and I've set this not to our Pulumi service because I don't want that included. This is just a visual mockup that's used to drive that IAC. We give it a name. We can set the notification policy that we want it to use. That's what defines, hey, when this monitor is triggered, who actually receives these alerts and things like that. And then again, to keep this simple, just a very easy query of, hey, show me the Pulumi workshop request where error is true. And because I built this application to fail about half the time, and we have Checkly running a synthetic test against it to produce traffic, we get some results here. Now we have our conditions, and I've set this to alert when the value is greater than or equal to 4 for 1 minute, and to warn when it's greater than or equal to 3 for 1 minute. One thing I didn't add, but that's also interesting, is our annotations. So because this is, related to a synthetic check, maybe I'd want to say, hey, here's the synthetic test in Checkly, provide that link so that if this monitor is triggered, you can go look at it there. I also might want to link directly to the Chronosphere traces service pages, all sorts of stuff like that. This is very flexible. If you have run books that you follow, or things like that, maybe playbooks, you can attach those here as well dynamically. But when we're done editing, we can grab our code config. And this is, again, just like the dashboard, we can pull this out, use it directly. It's flexible how we reference that. It'll open our IDE back up, pop open our monitor config, and this is where we would drop that in. Going back to our index, we've updated our file to uncomment the code that's going to actually create these resources. So now we can go back to our shell and we can run Pulumi up one more time. And this shouldn't take too long because, to Josh's point, everything's mostly already created. This is just the observability resources. So I'm going to say, yes, I want to perform this update, and it's only going to update these two resources. It's not going to try to redo or change everything that exists.
Right, and then likewise, a change to the any declarative change to, like, say, the JSON in the Chronosphere resources would also be reflected as a change in the in what Pulumi is going to do. But again, it would not try to recreate any of the other resources unless you forced some sort of property change that will trigger a recreate.
Yeah. So very helpful here. We can see this did succeed, right? And these two new resources were created. I can see the name of those resources in Chronosphere. And now I'm going to jump back in, and I actually want to check our service page. So I'm going to reload this. And what I'm hoping to see now is that we have an additional dashboard and an additional monitor from our IAC. Hey, and awesome, look. So now these resources have been created and associated with the service. I can open these up. They're going to look just like the ones we had previously, but you notice the name here changes, Pulumi Workshop Monitor versus our Pulumi Workshop Mockup. And same thing for our dashboard. I get my metrics right with my infrastructure and application deployment. And somewhere in here, we should have visualized where our service sits in relation to our other services. And here it is right here at the top. So it's not connected to anything else, but it does let us visualize our whole system in one spot. So in closing here, we can now turn this into a template where anybody who's deploying in a similar style using OTel can use this script, change their configuration items, and accomplish day one observability, and hopefully the use of Pulumi, meeting them in the language they've started in, as well as Chronosphere's cost control and ease of use, is going to lead to a longer term adoption and a longer term health of your platform engineering, observability, and infrastructure deployment as a whole.
And I think it's also worth noting that, like, for Chronosphere or any other sort of Pulumi resources, there are additional ways that you can kind of enhance the reusability of that code. So, in this example, we have just the raw Chronosphere resources directly in the Pulumi program, but you could also share that as a module that your application teams could then consume to add in the dashboards that they need for their workloads. And you can take it to different levels from there. Pulumi has this ability called the automation API, which allows you to redistribute Pulumi programs as executables. So, like, that, and then you can just set up the configuration via YAML or something like that. So there's a lot of different, like, a lot of different places you can go from here, from this sort of basic example. Ryan Page, I did want to throw up a few questions regarding Chronosphere that I thought were particularly interesting. So here we go. So Craig asks, is the cost analysis Chronosphere cost, or can it be metered API we use? I'm having a little trouble reading this one, but hopefully the
I think if I'm understanding your question, so we have, what we showed was controlling the cost within Chronosphere. So this is targeting your observability bill itself. If you're looking at targeting the spend in a cloud provider, we do have a few partners for that. but KubeCost comes to mind as well as some others. And we partner with cloud providers to get some of that information as well, so that you can look at cost control for your cloud providers and your observability platform together.
Ah, I see. That makes sense. And Carol had this great question that I just dismissed by accident. All right, here we go. So this question is basically about like, where does Chronosphere sit in the sort of continuum of like, DIY to like very curated kind of experience.
Yeah, Chronosphere is interesting because our founders initially built an open source project called M3. And we also have the founders and are the maintainers of Fluent Bit. So we rely fully on these open source tools with CNCF, but our platform is really built to remove the pain around scaling. So it is a paid SaaS solution that leverages open source collection. So it's kind of somewhere in the middle. We're also single tenanted, so we have very high reliability. That's another thing that stands out. So typically, the bigger and more complex your environment is, the more you invest in open source, the stronger a fit Chronosphere will be and the more value you'll get.
Awesome. All right. Excellent questions from the audience, by the way. Thank you. I wish we had more time for Q&A. But I will provide some path for you to get your questions answered if you just hang on for these closing slides here. First off, thanks everybody for joining us. We would love for you to continue your journey with Pulumi and Chronosphere. Pulumi has a community Slack. So if you want to hop in there and join the platform engineering channel, I'm in there. Ryan and Paige, you're invited to join. Also, are there any like community Slack or Discord, something like that, where folks could learn more about Chronosphere?
You can catch us if you're part of the CNCF Slack. We don't have our own like developer community or forum or anything, but you can also find Ryan and I on our socials and on LinkedIn and stuff. Lots of ways to connect.
Cool.
Yeah, and definitely say hello at any industry conferences and events. We tend to be around and have a booth, so I would love to say hello there as well.
Cool. And Pulumi is also at a lot of industry events as well. KubeCon EU is coming up, and Google Next as well. So we will be at both of those places. I will be at Google Next personally, if you'd like to come by and say hello. Also, if you don't have a Pulumi Cloud account, it's free for individual use forever. So do sign up and try it out. It's going to make getting onboarded with Pulumi, if you're new to it, as easy as possible. And there's really no downside. It is free for individual use forever. And then finally, please join us for another workshop sometime soon. We will have you will be kept informed of whatever we have coming up via your email. So just keep an eye out over there. Ryan and Paige, I wanted to thank you so much for your time. And I'd like to thank everybody in the audience for taking the time to join us. We know that you're really busy. And so we really appreciate you taking the time to learn more about Pulumi and Chronosphere. And with that, we're going to say goodbye. Thank you so much again for your time. Have a lovely rest of your day. So long, everybody.